Okay, let's look at 2.4. And I think 2.5 is very similar, so if you know how to do it here, should be pretty simple for the next one. So first you have to start LTSPICE. And I have to tell you that if you're using a Mac computer, it can be very difficult. And I highly recommend you either use a computer in the lab, on campus, or rent a laptop, a Windows laptop from the college. And I think it's about $50 one semester if you don't want to buy one, okay? But in the future, for the computer engineering program, I highly recommend you have a Windows laptop, or you want to probably use the Windows desktop in the lab. Okay, so I already started LTSPICE, and next I'm going to press this button to start a new schematic. I press F2 to bring up this library window, and next I will have to find out the components to form that logic gate. So the two components I have used in here is the PMOS4. Keep in mind, you don't have to know how it works for this class. It's going to be covered and explained in detail in engineering or CE241. Don't worry about that too much right now. Just follow, okay? So I have two, one PMOS, one NMOS that I can differentiate from looking at the arrow here is pointing out, it's a PMOS, it's pointing in, it's NMOS, okay? And again, you don't have to worry about how this works. Just need to bring it here and use emit connections and run the simulations. So now I've selected the PMOS and do Control R for twice to rotate it, and then I measure it. Keep in mind, you don't have to do this. It's going to work because it's a symmetric structure for the transistor, but I usually just want to do it because this is usually the right way to do the circuit simulation. You know what? You can actually making copies right now, but I wouldn't do that. I want to change the properties here first. So if you look at the 2.4's instruction, you can see it's 10 micron by 1 micron for the width and length. So I'm going to make the change. So the length is 1 micron and width is 10 micron. And that's it. And also we have to change the name of the PMOS to P_1U. And now let's change it. Okay, so now this is ready to use, but I still cannot see the dimensions. So the way to do that is control and right click the transistor and check this box by double clicking this space here. So you can see the dimension being displayed after that. Same to the NMOS. Let's just keep it consistent. So it's 10 by 1 as well. I'm going to do a 1 micron and 10 micron. Okay. And same for this one. I have to change it to N_1U, and I want to just display it. Okay, it should be Control right click. Okay, now it's ready to be copied because they are the same right now, and I just need one more of these without having all the settings. Doing that again because it's already done. And now I have all these transistors laid out in here, and next is just to make the connections. So you can press F3 on the keyboard, and to make the connections, make sure you are connecting the correct nodes together, but not the wrong ones, like the middle one. And again, you don't have to know why the middle one, I'm going to show you pretty soon, like this one, has to be shorted to the top because there are a lot of semiconductor physics involved in there. So for this class, we just need to do the connections. The PMOSes, you just connect the PMOSes to all the V high or V pulse, depends on how you name it. And for the middle pin of the NMOSes, we just short it to the V NIC or V ground. Okay. This is how we do it. Let's short it together and then together to the bottom. This is how we do it. Okay, and make sure you know that this is the output pin. So I press F3 again and bring up another line as the output. Make sure that you know this is output pin, not this one, not the middle one. Okay, I've seen a lot of mistakes from there. And now let's just get an extension of the traces before we are ready to name it or label it. Okay, And now I think we have all the terminals. The next step is just to rename, give them a name. So let's do v high for the top, and I put a v high here, but I will change it later. Okay, now I'll put it here and then right click, change it to v low, and I don't like it just right on the top, so I want to drag it. You know, you can drag it like this and drag here. Okay, so I got a v low, and then I need VA as one of the inputs, and VB here and V out here, right? Press escape, and then you can right click to change it to VB, and right click, change it to V out. So this will be a fundamental NAND gate, keep in mind, and you don't have to know why this is NAND gate for now in this class. Let's just assume that this is a NAND gate. And the next step is to change, let's save it on the desktop. You can save it in any of the folders we want it to be in. Okay, I'll just call it NAND. I'll save it on desktop, and then I will start a symbol schematic, and then I'm going to start drawing that NAND gate. Keep in mind, now it doesn't have a name for this file. I have to Control S, where you can save as, and have to be the same name as your schematic. Keep in mind, it has to be the same name. Don't type the extension, just type the name. All right, and save. Start drawing that schematic. Make sure that you make it in the right size. So now I want to have how many grids here? Like 5, 1, 2, 3, 4. So the middle one can be the circles spot. Let's just follow, and you will see why I do this. All right, and I'm going to stop here, and this one will start from here to here, and then I'm going to draw arc. I'll start from here and draw arc, and I'm going to stop here. Okay, and then you click in the middle, so you can only have half of the circle. It's like an arc, and then you move it back. Okay, and then I need a circle. So I'm going to just draw a circle like this big, and then I'm going to move it to the middle. No, I need to move it, so I'm going to select it. What about that? Okay, it works. Okay. The reason that I want to put in the middle is because you can see it has a little dot here, so I can start a line from the grid. Okay, and now all the structure here doesn't have any electrical property. They are just the drawings. And if you want to bring the electrical connections, like the ports, those ports, to this symbol in order to use them, and you have to add pins to them. You can press P on the keyboard and name them. It has to be the same name as the ports in the schematic. Okay, so let's do a VA first. Put a P again, VB, and I will do another P. I'll call it V high. Okay, I'll put it here, for example, and then I will make a V low. Okay, and then I still need a V out. Just keep it consistent. So I need all the pins to be displayed here. Okay, and then you can do lines again. Right? Just draw the lines, which doesn't have any electrical property. Just make it look like a NAND gate. Oh, that was not straight. I have to undo it. L. L. So this straight line is just a drawing. Okay, it's not making any connections. As long as you have the names in here in the symbol, as they're the same names, in the schematic, they will be performing like the ports in the schematic. They will do that job for you. And now I just make it looks like a NAND gate. So the next step is just Control S to save it. And now you can see I have this structure already done. So next step is I want to test if this works. I'm going to start a new schematic. Okay, and I'm going to go to press F2, but I have to find it on the desktop. So keep in mind, you have to put them in the same folder in order to make a connection between of them. So now I'm going to desktop, and I'm going to find this NAND gate. So now you can see it's like a library component I can use. And then let's verify it. Let's come back to this main library, and we have voltages here that I can use. Okay. So we need 3 signals. One is the voltage power supply and 2 signals. And they need to be grounded to the common ground. Don't worry about that for now. And let's power it up at 5 volts. And let's name this, let's give this one a pulse. Go to advanced, pulse, initial like 0 volts, and jump to 5 volts, and no delay. And T-rise, just make a sharp 1 picosecond for each, and T-ons, like let's make it 10 microseconds, and this is another 10 microseconds. Oh, the period should be longer, should be twice as much as T-ons, right? Let's make it 20 microseconds. All right, so this is the first signal SPICE code. All right, and now let's move this down a little bit. And now I can right-click this guy and copy, right? And right-click this guy and paste. So now we just need to change the time delay here to have otherwise if they're overlapping, you're not testing the signal combinations. Let's just make a little, like 5 microseconds of time delay, so you can explore all these different combinations of the inputs. And now we need the labels to make the connection. If I put a VA here, and this one will be automatically connected because they have the same name. You don't have to wire them up. Okay. Same thing. These ones has a name inside the symbol, but not here. So I have to label them as well. Okay. This looks odd, but this is something I have to do. And same for the, let's call it VDD as the power supply. It's 5 volts, right? I have one here, and I have to put one here as well. And this one need to be grounded. And I need a wire. I need a label for VL so I can probe it, and I can see the signal in my simulation. And now I want to drag it a little bit so it's not confusing people too much. Okay, so these are the ports. And that's a ground pin. And that's V out. Okay, and we got the power supply, we got signals, and I think we need a SPICE code. So let's do a transient analysis. So the x-axis is time, and because we have 20 microseconds for each period, so let's just run for 100 microseconds. We're gonna 5 periods in there. All right, and also don't forget to include the model file. It's called model.txt. If you have a different name for it, you just use a different name. But now I think we have, what I have here is it's model.txt. Okay, I'm going to just put it here. I want to make sure that that model.txt is on the desktop, and it is here. So they are in the same folder. Okay, so it's going to work. And let's come back, try to run it. Something didn't work out, so it's a good debugging process. Let's take a look. Come back to here. It's V high, V low, V A, V B, V out. Oh, we didn't. Interesting. Let's come back to the model and see if we have these names. N1U and P1U. It works. Ah, there's a typo here. Oh my god. Run. Okay, now it works. Let's come back, and add signal, we can probe it. Probably that'll be easier. Let's probe VA, probe VB, and VOut, and now let's see if it's a NAND gate logic. Right? I can right click and add panel pins. Add panel pins, VA, VB, and let's change the y-axis by right click it and make it 6 volts, so you can see the 1 zeros. Same to these guys. All right. So NAND gates, whenever you have 1 1, it becomes 0, and 0 1, it's a 1, right? Just ignore all these spikes. It's okay. And this is 0 0, it's a 1, 1 0, it's a 1, which works. So this is non-logic, no problem. Okay.